Have you ever wondered how the universe can expand faster than light without breaking the laws of physics? Let's delve into this cosmic conundrum. The universe's expansion is not about galaxies zooming through space at unimaginable speeds. Rather, it's about the space between galaxies itself stretching out. Imagine pulling on either end of a balloon. The surface expands, but the points on the surface aren't moving through space, they're being carried with it. This is how the universe grows. Space itself is expanding, pushing galaxies further apart over time. So, how does this expansion not contradict the speed limit set by the speed of light? Let's explore. Scene script. Imagine throwing a ball in a stretching corridor. The ball moves, but the corridor itself also extends. This visual helps us explore a fascinating aspect of our universe, the difference between the movement of objects through space and the expansion of space itself. Let's simplify this further. When we talk about objects moving, like a planet orbiting a star or a car driving down the road, they're moving through space. This space is like the air in the corridor, providing a medium through which things can move. Now consider the expansion of space. It's not about objects moving through space, but space itself getting larger. Think of it as the walls of our imaginary corridor stretching out. This stretching is subtle but constant, and it happens everywhere in the universe. Here's an interesting twist. While objects are limited by the speed of light, thanks to the rules set out by Albert Einstein, the expansion of space itself isn't bound by these limits. This means that on very large scales, like across galaxies, the space between objects can expand at a rate that effectively separates them faster than light could travel. This leads to a universe where distant galaxies seem to recede from us faster than the speed of light. However, it's not that these galaxies are speeding away, rather, the space between us and them is expanding. While the ball, galaxies, moves at a certain speed, the corridor, space, can stretch at a different rate, sometimes even faster than the ball can travel. Albert Einstein declared a universal speed limit, the speed of light. But did he restrict space itself? In the tapestry of the cosmos, Einstein's theory of relativity plays a crucial role, setting the speed of light as the ultimate speed limit for any object traveling through space. This limit clocks in at about 300,000 kilometers per second. It's a boundary not just for physical objects but also for information itself, encapsulating a fundamental principle of the universe's structure. However, when it comes to the expansion of space, the rules bend in fascinating ways. Einstein's equations, which form the backbone of his theory, actually allow for the fabric of space itself to expand at any rate. This expansion isn't about galaxies speeding away from each other through space, but rather, space itself stretching, a concept that doesn't require the movement of mass at velocities surpassing light speed. This distinction is crucial. It means that while no galaxy can outpace light within the space-time fabric, the space between galaxies can expand such that they recede from each other faster than light. This doesn't violate relativity because the cosmic speed limit applies only to the movement through space, not the expansion of space itself. Thus, the universe can expand at rates exceeding the speed of light without defying Einstein's principles. How do we measure something as vast as the universe's expansion? It's a question that tickles the intellect and stretches the imagination, much like the universe itself stretches the fabric of space-time. To grasp this cosmic scale, astronomers use a variety of methods, each peering into the universe's grand design. One of the key tools in this astronomical toolkit is the observation of distant galaxies. By looking far into the cosmos, astronomers can observe galaxies billions of light years away. Now, these aren't just any ordinary observations. What astronomers are really on the lookout for is a phenomenon known as redshift. So, what is redshift? Imagine the sound of a passing ambulance. As it moves away from you, the pitch of its siren lowers. This is a similar principle with light from galaxies. As galaxies move away from us due to the expansion of space, their light stretches towards the red part of the spectrum. This shift towards the red end is what astronomers call redshift. The further away a galaxy is, the faster it appears to be moving away from us and the greater the redshift. By measuring this redshift, astronomers can calculate how fast the universe is expanding. It's like a cosmic detective story, where light itself holds the clues to the universe's expansion rate. These measurements have revealed an astonishing fact. The further galaxies are, the faster they are receding. This observation led to the revolutionary conclusion that the universe is not just expanding, but it is accelerating in its expansion over time. These measurements help us understand that space itself is stretching, pushing galaxies further apart. This isn't just about galaxies moving through space, it's about the very space between them expanding, an idea that reshapes our understanding of the cosmos. What does it mean for us if parts of the universe are expanding away from us faster than the speed of light? Let's dive into the implications of this mind-bending phenomenon. Firstly, consider the concept of the observable universe, which is essentially the region of space from which light has had enough time to reach us since the beginning of the universe. As parts of the universe expand faster than light, they can stretch beyond this observable boundary. This means galaxies that were once visible to us are gradually moving out of sight, effectively disappearing from our cosmic horizon. This expansion isn't just about losing sight of distant galaxies, it's about the fundamental limits of our cosmic knowledge. Every galaxy slipping beyond the observable universe takes with it secrets about the cosmos that may never be uncovered. This reshapes our understanding of the universe's structure and evolution. Moreover, the increasing size of the observable universe raises questions about what might lie beyond that boundary. The parts of the universe that expand beyond the reach of our observation could contain phenomena or laws of physics that differ from what we know. This unobservable universe challenges our understanding of the cosmos as a unified entity. As we consider these implications, it's clear that the universe is not just expanding, it's stretching the very fabric of our comprehension. Each galaxy moving beyond our view is like a story left unfinished, a reminder of the vast, unexplored depths of space and time. This expansion challenges our understanding and opens up profound questions about the nature of our universe. Today, we've journeyed through the stretching cosmos, tackling a mind-bending concept. Let's briefly recap the fascinating exploration into how the universe can expand faster than light, a question that stretches the very fabric of our understanding. Firstly, the universe isn't expanding by galaxies shooting through space at unimaginable speeds. Rather, it's the space between galaxies itself that is growing. This expansion is a subtle yet profound distinction that reshapes how we perceive cosmic movements. Albert Einstein's renowned theory of relativity sets the speed of light as the ultimate speed limit, but crucially, this limit applies to the movement of mass within space, not to the expansion of space itself. Space can expand at any rate, even exceeding the speed of light, especially over vast cosmic distances. This doesn't break any cosmic speed laws. Instead, it opens a new chapter in understanding the dynamics of our universe. The universe continues to mystify and inspire us, pushing the boundaries of our understanding and our curiosity.